Hi, class. So today what we're doing, if you're watching this, I'm in Ireland, so I'm sure I'm having a great time. So if you hear a bunch of movement in the background, I have 4 dogs. They're all labs. 3 of them are my daughters, and I'm watching them today. So anyway, I wanted to put this video out there so that while I'm in Ireland, you still have the same type of teaching that I would be doing if I was in the States. So I'm going to share my screen and we're going to get started. We're starting today on section 1.1, which is our solving linear equations section. So what I wanted to do, I'm going to back up just a little bit and just show you a technique on eliminating fractions. And this will be super helpful to you. Let me clear my spot here. Super helpful to you as you're working through some of these linear equations and inequalities. Okay, let me get this all set up here so that we can see it. Now, again, just like with all the other ones, if you want to print these up, you certainly are able to. Here's a Word document, and then here's a PDF. So whichever one you need to be able to print, you can print those and kind of work like we would in a regular classroom. You would have these handed out, and then you would go ahead and work on them with me. So, okay, so sometimes what we have in a linear equation or a linear inequality is you have one that is set up as a fraction. And so these make it a little bit more difficult to solve, only because you're dealing with fractions. And so there's a really easy way to be able to get rid of that so that you don't have to work with the fraction. So what I'm going to do is I'm going to use a different color, and I'm going to take this fraction, right, this equation, because it's got an equal sign, and I'm going to look at the denominator. So remember, the denominator is the bottom number. So my 3 denominators are 2, 3, and 6. So what I want to do is I want to go, okay, I want one number that all 3 of those will be divided into evenly. Okay, so in other words, I'm not going to use 2 because 3 can't go into 2. 6 can't go into 2. I'm not going to use 3 because 2 can't go into 3, and 2 can't, or 6 can't go into 3. But if I use the number 6 as my least common denominator, what I can do is I can go, oh, 6 divided by 2 is even. 6 divided by 3 is an even number, and 6 divided by 6 is an even number. So whenever you're looking and trying to find out, okay, what's the least common denominator, look at your biggest number and start seeing, okay, what are the multiples of that biggest number that the other 2 will go into. Okay, so it's you have to, that's why you have to know your math facts. You have to know your multiplication tables. It makes it much easier. Okay, so what we're going to do is we're going to literally multiply through. I'm going to move this up a little bit. You're literally going to multiply this 6 through every single term. Okay, so I'm going to write it over here. So I'm going to go 6 times x, and still, okay, I haven't eliminated the denominator yet. All I'm doing is I'm setting it up so that I can. And then 6 times x again over 3. And then 6 times 1 over 6. So you can see all I did is I multiplied every single term on top by my least common denominator. Now I can cancel. Because I've multiplied all terms through by the same value, I haven't changed the value of the equation. All I'm doing is changing how it looks. Okay, so now I can cancel. 6 divided by 2 is 3, and then my x comes along. 6 divided by 3 is 2, and again, the x comes along. 6 divided by 6 is 1. So you can see those just cancel. So another way to look at this is, let me change my color, is I divided. 2 goes into itself once, 2 goes into 6 3 times. So that's where I get my 3x. 3 goes into itself once, 3 goes into 6 twice. That's where I get my 2x. And 6 goes into itself once, and 6 goes into itself once, and that's where I get my 1x. So once I reduce, now I'm just multiplying. 3 times x is 3x. 2 times x is 2x, and 1 times 1 is 1. Now, if you notice, I have a straight equation. I have no problem adding like terms. So 3x plus 2x, that is a total of 5x equals 1. And now it's just a one-step dividing both sides by 5. That cancels, so I get x equals 1/5. Okay, so that is the value. If I plug that into here, these two sides would equal each other. So I was able to solve, even though I started out with a fraction. All right, so let's try another one. So each of these I'm going to kind of build on. I know one of the complaints with math is, oh, they never look the same, but the process is always the same. You have to trust the process because the process will never let you down. All right, so here we go. Again, I'm going to change my color so that we can keep it moving here. Okay, so I look at the numbers and I go, okay, 5, 10, and 15. So I look at my largest number, the 15, and I go, all right, 5 will go into 15, so that's looking pretty good, but 10 won't go into 15. So you have to have one number that all three of these denominators will be divided into evenly. So now I talk about the multiples. So 15 times 1 is 15. We know that's out because 10 won't go into 15 evenly. 15 times 2 is 30. So now you go back and you go, okay, 5 goes into 30 evenly, 10 goes into 30 evenly, and 15 goes into 30 evenly. So 30 is our least common multiple. So that's what we're going to multiply across the top so that we can eliminate our fraction. And this will work whether you have an equal sign, or it'll even work with the inequality sign. If all you have is an expression, so there's no equal sign or no inequality, that's when you have an expression, this technique won't work. You have to have an equal sign or you have to have an inequality sign for this technique to work. Okay, so again, all I did is I have a least common multiple of 30, and all I'm doing is I'm multiplying that 30 by every single term in the top. And I rewrite my denominator, so that hasn't changed. And now I can reduce. 5 goes into 30 6 times. 30 divided by 10 is 3. Or I can say 10 goes into 30 3 times. 30 divided by 15 is 2. Or 15 goes into 30 twice. And then all I'm doing is multiplying, dogs growling at each other, multiplying the top through by what's left. So 30 divided by 5 is 6. 30 divided by 10 is 3. And 30 divided by 15 is 2. Hang on one second. One of my daughter's dogs is an old lab, and he's a grump. So he growls sometimes. Okay, so here we go. This is the life of a Zoom class. All right, so 6 times 3x is 18x. 3 times 2x is 6x, and we're adding those. And 2 times 3 is 6. So you can see, again, we're right back to where we were with the first one. Now we can add our like terms. So 18 and 6 is 24x equals 6. We divide both sides by 24. And notice I always divide by the value next to the x, because what's the goal? The goal is to get that x all by itself. So my x is 6 over 24, which, remember, we can reduce it. It's not simplified yet. 6 goes into itself once. 6 goes into 24 4 times. So my x equals 1/4. Okay, so this is a very easy technique. It looks a little complicated, but once you get going with it, you'll be very happy, because it takes a very complicated equation or inequality with fractions, and it breaks it down to where we have just a straight equation. Okay, here we go. Let's try this one. So again, look at your denominator. Your denominator is 7 and 14. 7 does go into 14, so look at your bigger number and see if the other numbers will divide into it evenly. So 7 does go into 14, so we're good to go. Now, this is the first time we have a whole number. So a whole number is literally a whole number over 1. So the whole number doesn't affect my denominator because, in other words, 1 will go into anything. So as long as my least common multiple is good for both the 7 and the 14, then I'm good to go. So 7 goes into 14 and 14 goes into 14 and 1 goes into 14. So the 1 isn't going to affect it. So here we go. Again, I'm going to multiply the least common by the 14 by every single term. Otherwise, this is not even. Okay, if I multiply everything by 14, I haven't changed the value of it. It's still an even balanced equation. Okay, so now I can reduce 14 divided by 7 is 2. 14 divided by 14 is 1, and you can write it or not. And 14 times 2 is 28. Okay, so notice I'm dividing on this side, and this side I multiplied, right? Because this was 2 over 1. 1 goes into 14, 14 times 2 is 28. So now I can simplify this again. So 2 times 3x is 6x plus x equals 28. I can add my like terms. 6x plus 1x is 7x. And now I divide both sides by 7. So x equals 4. 28 divided by 7 is 4. Okay? Now, you can always check this. If you aren't sure if you're doing this correctly, you can always check it, which means you take your answer and you plug it back into the equation and see if it works. So I'm going to do this. Let's see if I can move this over. I'm going to do this over to the side here, and I'll do it in a different color. Okay, so I'm just going to check number 3 here. So 3 times 4 divided by 7 plus 4 divided by 14, does that equal 2? That's what I'm asking. Because remember, this value satisfies or is the solution to this fraction equation. All right, so it should work. It should work. So 3 times 4 is 12 over 7 plus 4 over 14 equals 2. Well, 4 over 14, I can reduce that. So I have 12 over 7 plus 2 over 7. So do you see I just divided both top and bottom by 2? 4 divided by 2 is 2. 14 divided by 2 is 7. So this is knowing your divisibility rules. These are both even numbers, so 2 will go into both of those evenly. And again, I'm asking, does that equal 2? Well, if you add fractions, remember, you have to have a common denominator. So 12 plus 2 is 20. Oh, it's 14, sorry, not 24. Erase that. Okay, so 12 plus 2 is 14 divided by 7. Does that equal 2? Well, yes, 14 divided by 7 is 2. So 2 does equal 2, so it checks. So whenever you're doing these fractional equations or inequalities, you can always check your answer. If you aren't sure, plug your answer back in and it should come up the same. If it doesn't, that means maybe a sign was wrong, or maybe you multiplied wrong or divided wrong. So at least you have a way to check it. So you should never get these incorrect. Okay, so that's kind of the basic ones. Now I want to take it one more step because you will see these. So this is, notice now I have a binomial on top, right? A 2-term polynomial. So now it looks like it's a lot more complicated. So the key with this, here's the key, is always put parentheses. Whenever you see a term all in the numerator, that you have to look at that as one unit. You can't separate those pieces out. That's one unit. So you need to put parentheses around it. So now when I look at this and I go, okay, I need a number All right. I need a number that 3, 14, and 3 will all go into. Okay, 3, 14, and 3. So again, you look at your bigger number, the biggest number, and go, all right, well, 3 won't go into 14 evenly, so we have to get creative. Well, if there's no other values, remember the multiples of 14, so 14 times 2 is 28. Well, can 3 go into 28? You can check it. It does not. How about 3 times 14? Well, right there you have it, because you have the least common multiple. So 14 times 3 is 42. I just wanted to double check, make sure I'm right. Okay, so now what I'm going to do, I'm going to use a different color over here. Now what I'm going to do is I'm going to multiply 42 by that whole thing on top. And this is where your putting it in parentheses will really, really help. Okay, because now you can see it's not just the x times 42, it's the whole thing times 42. So you're going to have to do distributive property. So 42 times 3x minus 1 all over 14, and then 42 times 2 over 3. So because we did 3 times 14, we know that 3 goes into 42 14 times. 14 goes into 42 3 times, and notice I'm keeping those parentheses in there, and then 42 times 2 is 84. Okay, so you can see there's another layer to this, right? But the process is the same. I'm looking at my bigger number. I'm finding a value that all the denominators will divide into evenly. Okay, and in this case, I just multiplied 14 times 3 to get 42. And now I have a straight equation. Well, now I have to distribute. So 14 times x and 14 times 4. So 14 times x is 14x. 14 times 4 is 56. And then I do the same thing here. I'm going to distribute this 3 through. So 3 times 3x is 9x. 3 times -1 is -3. Okay, so now I'm going to add my like terms. 14 plus 9 is 23x. 56 minus 3 is 53 equals 84. So now I'm going to subtract 53, and I get 23x equals 31. Yeah, 31. And then divide both sides by 23. So my x equals 31 out of 23. And because these are prime numbers, I'm just going to leave it. You don't have to reduce it. You don't have to make it into an improper fraction. Just leave it as a top-heavy fraction. It's totally fine. Okay, so one more layer is all it is. Now we're just multiplying through the whole term on top, making sure we distribute through both. And notice I didn't distribute the 42 first. I reduced the 42 divided by 3 first. Got 14 and then distributed. Same thing here. I reduced 42 over 14 and got 3 and then distributed. It makes it much easier, much, much easier. Okay, last one. So we're going to find a common denominator. So in this case, my bigger number is 8. 4 does go into 8. So I'm going to use 8 as my common multiple or common denominator. So let me change my color here just to keep them separate. So 8 times, and then remember we are putting these in parentheses. Now, if you notice, this is a subtraction problem. This is where those parentheses are going to save you a lot of heartache. Okay, so always put your binomial, trinomial, whatever it is on top in parentheses. So 8 times 2x minus 1 over 4 minus 8 times x plus 3 over 8, and then 8 times 5. Okay, and again, because this is a whole number, the denominator isn't going to so now I'm going to reduce. 8 divided by 4 is 2. And again, the 2x minus 1 stays in the parenthesis. 8 divided by 8 is 1. And again, keeping that in parentheses. And 8 times 5 is 40. So now, here's our new layer. We're going to distribute that 2 through both of those. So I get 2 times 2x is 4x. 2 times negative 1 is a negative 2. I'm still distributing this negative through, and I like to say push it through. So negative 1 times x is a negative x. Negative 1 times 3 is a negative 3 equals 40. Now I'm going to add my like terms. So 4x minus x is 3x. Negative 2 and negative 3 is a negative 5 equals 40. Now I have a two-step equation. So I get 3x equals 45, dividing both sides by 3. I barely made it. So x equals 15, because 45 divided by 3 is 15. Okay? So there you have it. That is eliminating fractions. And I'm going to stop there and then I'll restart.